Okay, then for the strength of different material, okay, so each material have their own analysis of strength. Okay, so for the steel, for example, for the steel, we will analyze it based on the tensile strength, tension stress. For the concrete, we analyze it based on the compressive, tekanan, compress. But then for the soil, we generally analyze it based on the shearing. Shearing is sliding each other, the geseran. It's like a friction or geseran. Okay, so why we always refer soil as shearing? Okay, because it's normally happen failure in shear condition. Okay, for example, we have the retaining wall here, and this is the slope. So the purpose of retaining wall to sustain the slope from the failure. Okay, but the movement of the soil is normally due to gravity, dia akan slide down ke bawah. So we need to have the shear resistance, okay, to ensure that the retaining wall ni tak boleh fail. Sama juga kalau footing, dia akan berlaku shearing, settle ke bawah, and we have to ada resistance to ensure that the foundations are not fail. Okay, so material that have strength can sustain the shear stresses, and strength is the maximum shear stress that can be sustained. Okay, so we have the shear stress. But then, what is the shear strength? Shear strength is the maximum shear stress. So soil generally fail in shear. So this is the shear failure mechanism. Okay, the tau is the shear stress and the movement sliding each other. And so this is the normal stress. So at failure, shear stress along the failure surface reaches the shear strength. Okay, so the significance of the shear strength for the geotechnical structure, the safety of the geotechnical structure, okay, especially on the earth retaining structure, for the slope stability, foundation, and also for the pavement. So this is an example of the shear strength failure. Landslide, rockfall, landslide, landslide, okay, failure of the retaining wall. So the shear strength in soil derive from two sources. Ada two factors that control the shear strength. We call it as the cohesions and also the frictional resistance or the friction angle. So what is the cohesion? Cohesion C. It means the bonding between the particles, the cementation between particles. Okay, so just imagine, compare with the sand and gravel, or also with the fine particles. Knowing that clay in natural condition there are some amount of water, so the bonding is very strong. They sticky, they melekat, bonding together. Compare with the sand and gravel, it's a granular, maknanya berbiji. So there is no other cementation yang membuatkan dia boleh melekat rapat as like fine particles. Okay, so the cohesion between the particle for the sand and gravel normally is equal to 0 or in a very small amount. Compare with the fine, normally the C value is more than 0. And the frictional angle, the friction angle between the particles, and the friction, the geseran, the angle between the particles. So normally for the granular particles like sand and gravel, the friction is besar compare with the fine particles yang since it's sticky and then very kita panggil licin kan, so the friction angle dia normally rendah. Okay, so C and angle of friction, so this is the symbol for cohesion and this is the symbol for the friction angle. Measure the shear strength. The higher the value, higher the shear strength, and it also depends on the type of soil and also the permeability of soil itself actually. Okay.